reminding you of this little scenario. The less negative it is, that's called depolarization. Then it resets, that's called repolarization. Then if it goes more negative, which it will, more negative is called hyperpolarization. So just make sure you have those scenarios, those words in your mind. And then showing you again, if it goes less negative for any reason, that's called depolarization. If it goes more negative for any reason, that's called hyperpolarization. All right, if sodium comes inside a cell, what is a membrane going to do? Now, we already talked about this, but let's see if you remember. Sodium comes inside a cell. I may need to go back over there and fix my cell because I've been messing with it quite a bit. There's sodium going in. So what happens? And we have our critical thinking. I don't know if y'all knew these were critical thinking questions. All critical thinking is just, I know this, maybe I know this, therefore I can answer this. So first thing is, I know what these words mean. See, that's the first part of critical thinking. Then this one says, and I know what the scenario of ions is with a cell. And so now I just have to think about, all right, if the sodium channel opens and sodium comes inside a cell, what does it do to the membrane, and then what is that called? And that's all that critical thinking is. I actually do it all the time. I know that, I think we talked about this in this class. At the nursing program, they really have a tight grip on everything that goes on because they're accredited by an outside agency which looks at them very closely. So your first semester, 25% of your test questions are critical thinking. In your second semester, it's 50%. In your third semester, it's 75%. And in your fourth semester, it's 100%. So maybe that first semester, you'll get to have some definitions. By your third and fourth semester, there won't be any more definitions on a test. You have to be able to apply everything you know. And you know what else? All the answers are correct. Multiple choice, all 4 or 5, whatever, they're all correct. But one is more correct than the others. One is the one you do first. You do all 5, but you do one of them first. Yeah, making you appreciate me just a little bit more, aren't you? Okay, that person's still thinking. Good. It's called depolarize. Because, there's depolarize, when sodium goes inside the cell, it makes the cell less negative. It may not make it all the way up to positive because we're not that far yet. We will. But it makes it less negative. So that's called depolarize. So now we're ready for the graded potential. This happens on the dendrites and the cell body. You've had anatomy and you've had an online lecture which tests you about this neural anatomy, so now I expect that you know what a neuron looks like. So the graded potential is only on the dendrites and the cell body, the membranes of the dendrites and the cell bodies. It does not happen on the axon. The axon is a different potential. So in that dendrite cell body, the more sodium comes in, the bigger the change in the membrane. It becomes less negative. So the way that a neuron is going to respond in our graded potential scenario for a neuron, this is not going to be true for anything else we talk about, but yes, for a neuron, it's sodium. Any stimulus opens sodium channels. A stimulus opens sodium channels, sodium comes in following its electrochemical gradient, and it makes the membrane less negative. Okay, so all I did was take depolarization, I added one more step at the dendrite cell body. That's all I've added. Then the bigger the stimulus, the more sodium comes in. So this versus that. more sodium came in when I did this. One time I was doing this with a pen, was demonstrating, and I did like this, and I actually poked a hole in myself. Don't do that anymore, just use your fingers to illustrate that. All right, and this is just like a rock in a pond. When you drop in the rock, the bigger the splash, and then what happens? Ripples. And the farther away you are from where the rock went in, the less ripple there is. There's a big ripple right where the rock went in, and then less and less, and less until the ripple's gone. That's also what a gradient potential does. That's what it means by decreased intensity with distance. There's less and less sodium coming in as we get farther and farther away from the stimulus, and the membrane is being corrected.